This is Stephen. In the last video I showed you how to use the UartRemote library, and now we'd like to show you how to use that library to drive some LED. So I have here a round LED circle, it's 12 LED LEDs, and I would like to drive that by turning a motor which is connected to the Lego Mindstorms. The Lego Mindstorms sends a command through UartRemote to the LMS-ESP32, which lights the corresponding LED on the LED circle. So that's the thing we are trying to achieve. What you see here is the left side. You see the Lego Mindstorms Tony ID, and the right side you see the ESP32. So let's first try to drive an LED on the ESP32. For that I imported the NeoPixel object from the NeoPixel library, and we need the pin, that's a GPIO pin, to which we connect the NeoPixel. NeoPixels are RGB LEDs which can connect it in a chained way, so you only have to connect one output pin to drive multiple LEDs. So if I initiate this program, I can create an object which is a NeoPixel object, and it has two parameters. The first is the pin, so I connected the LED circle to pin 21, and the second argument is the number of pixels in the LED in the NeoPixel strain, and that's 12. If you look at the LED circle, you don't see anything happen right now. What you get is the NP acts like an array, so I can initialize array elements with a tuple of 3 colors, RGB, for instance 100, 0, 0. That will get me a red pixel, red, green, blue, and the values are varying between 0 and 255. For very bright, 255, 0 is off. So I only have here the red color lighted. Still, you don't see anything happening until I issue a write command, and then it sends this NeoPixel array to the LEDs. And now you see one pixel is lighting up. If I, for instance, would initialize pixel 1, so the second pixel to 0, 100, 0, I would get a green pixel, only until I write pixels. So now you see the second pixel might get a little bit overlighted with the camera, but you get the idea. So I can write them again by resetting them. I don't think there's a command to wipe all the pixels, to erase the pixels at once, but it should work like this. So what we need to do is, if we want to light the pixel corresponding to an angle of the motor, which we will receive, we have to make a small function that, based on the angle, calculates which pixel it has to light up. So the LED number is, we only need integer values of the angle divided by 360 degrees, 12 LEDs. So that should give me the LED. Then first I wipe all the pixels in the NP array. So I initialize them on value 0, 0, and only the pixel with the corresponding LED we set to, for instance, 100, 0, 0. So only red LED, and then we write the values to the physical LEDs. So we can try if this function is working. It's probably angle divided. Oh, yeah, it's missing. So there's always the risk of programming it while you are recording that you make a mistake. So if I say 100, let's see, is this, if I say 50, 0, 359, which is an edge case, it's the other one. So that seems to work. 300, okay, so this seems to work. What I now want to do is, on the Lego side, I have to switch it on back on. I want to read out the angle of the motor. So if I turn this wheel, that it gives me the angle back. That angle will be sent from this side through the UartRemote library to the other side. So let's see whether we can get the angle of the motor. I use for this, I use the motor class. So if I run this, I have a motor connected to the port A. I still know why this is happening, but okay, maybe let's check whether no, I have to reboot probably. So this is usually it boots like this in the Tony environment, and these are all the sensors that are continuously written to the screen. So if I press Ctrl C, I can break that. And let's see whether now it works. Okay, so I have a motor A, and I think I've got position. I get the position in degrees. So let's see, it's 277. I turn a little bit, and it changes. Okay, so what I would like to do is I would like to make a while loop, an endless while loop, and I want that if I press the button, the left button, that it stops, so that I can stop the loop. So I say hub button left was pressed. If I press left button, it's true. So now I can detect whether the button is pressed, and that's while it's not being pressed, I loop, and in this loop I'm going to say the angle is the motor position. I'm going to implement on the LMS side. I will implement a command LED. So I can call LED, and I want to send the angle as an argument. So I used wrapper just to be safe, and it will send the angle to the other side. And that's it. If I do it too fast, the serial line get congested, so I like to implement just a sleep of 50 milliseconds, and that's it. So it keeps looping. You could also print the position so that we see what's happening. It will slow down the program significantly, but for debugging purposes that's alright. So let's see whether this is working. Still, I don't have a listener here. So what I would like to do is to implement the LED command. And that's just add the LED function. It doesn't have any argument. It doesn't give any argument back, so I don't need to bother about the other arguments. That's enough. And I keep looping and keep waiting for commands. So if I would do this, this side should be waiting for an angle from the other side. So if we could try and send a call, and that seems to work. If you see here on the camera, another LED is being lit. So let's try if this is working. the while loop. Should be angle. That gives me back, if I now turn on the, you can see the LEDs and the motor simultaneously. You see that it's, so what's happening now is that the angle of the motor is read by the Lego Mindstorms, and the Lego Mindstorms sends a call to the LMS-ESP module, which picks it up and calls the internal function LED to light up the corresponding LED corresponding to the angle. And it seems to work quite fine. So this is an example of a simple program to do that. What we could do here is, again, to put this program on the LMS side in the main program. So save it as main, so that it's on the MicroPython device. Oh, I have to stop it first. Main.py. And now if I reset the LMS module, it keeps waiting for commands. So if I run this again, it should still work. Oh, there's some problem. Oh, I see. The problem I have here is that I didn't initialize the NP object, and therefore in this LED loop it will make some errors. So it gives this error. This is nice. It gives this error. This on the ESP side, it passes it to the Lego side. So even here you can see that something's wrong on the other side. So this should be it. So I reset it again. Let's try. That seems to work. Now, I hope this is a little bit in view. So this works. So now you could plug in your ESP module in the Lego Mindstorms and get it running. There's only a program running on the Lego Mindstorms side. So this is an example of how to achieve that. I hope you enjoyed this video, and next thing I will explain is what would happen if you would have multiple applications simultaneously or used alternately.